Now let's use the binomial theorem to prove an important result. It says that we have to prove that 1 plus 1 by n whole to the power n as, this is not x, this is n, as n approaches infinity is equal to e, which is a constant in mathematics, which results in something like 2 point something something. It's in your calculator, you can find out the exact value, but we have to prove this. So first we'll apply the binomial theorem on this 1 plus 1 by n to the power n. When you apply the binomial theorem, you get this 1 plus n into 1 by n plus n into n minus 1 by 2 factorial into 1 by n to the power 2, and so forth. You basically just keep on multiplying the numerator over here with n minus 2 in the third term, n minus 3 in the fourth term, n minus 4 in the fifth term, and so forth. And in the denominator, you basically just take factorials of numbers consecutively. So for example, in the third term over here, you get 2 factorial, in the fourth term you get 3 factorial, in the fifth term you get the fourth factorial, and so forth. And basically the term 1 by n, you take powers of n minus 1 as well. So the power of 2 in the third term, the power of 3 in the fourth term, and so forth and so forth. We've discussed binomial theorem before, and if you need to refer, you need to find out what the binomial theorem is about, you refer to that lecture. Okay, but for right now, we've expanded this term binomially, right? Now, when you take some terms common, it will help, because this n and this n are cancelled out, and you're left with 1 over here as well. Okay, and you can write this term down as 1 over 2 factorial. So you can take this one over here, and this 2 factorial over here outside, and you can then just basically multiply this. So basically now you have n into n minus 1 over n, and when you basically just expand this further, you get 1 minus 1 by n, right? And when you do these simplifications on and on for the fourth term, the fifth term, and sixth term, you basically just get more terms that are like this. Okay, so for example, the next term after this term over here would be 1 by 4 factorial into 1 minus 1 by n into 1 minus 2 by n into 1 minus 3 by n, right? So for example, the next term that let me just write it down for simplicity's sake, right? Into 1 minus 1 by n into 1 minus 2 by n into 1 minus 3 by n, right? This is, and so forth, right? You get the gist. Now, when you apply the limit as n approaches infinity on the 1 by n terms, or the 2 by n terms, like this term over here, and this term over here, this term over here, any term with n in the denominator, right? They all tend to 0, because anything divided by infinity becomes 0, right? So all these terms become 0, and you're eventually left with this, right? And when you add up all these terms, as you can see, the number is becoming smaller and smaller, because the denominators are getting larger and larger, right? So we will approximate this, and what this approximates to is e, which is 2.718281, so forth and so forth. So the approximate value of this is e, and that's how we've proven that 1 plus 1 by n to the power n as n approaches infinity is equal to e.